So this is another type of question that comes up with relative velocity. It is with two independent bodies, but it's the shortest distance. So this is the second part of this. So when we're looking to get the shortest distance, we have to do three things. We need to create a triangle using the distance between the two bodies at a certain time, and they'll give us that in the question, or they'll give us a way to find that in the question. We will also use the VAB line, or the velocity of A relative to B line, or if it's P and Q or whatever. And then the third thing we'll need then is a line at right angles to this VAB line. And this is going to be the shortest distance, because we know the shortest distance is always at 90 degrees. So let's use this information now to look at this question and answer this question. The first three parts we should already know how to do. So if you want to pause the video and do those three parts, you can. And we are going to then go through the final part. So looking at this question here, we have a ship moving north at a constant speed of 20 kilometers per hour. We have another ship, Q, is moving southwest at a constant speed of 10 root 2 kilometers per hour, and at a certain instant, P is positioned 50 kilometers due west of Q. So once I see something like that, I'm thinking shortest distance. So the first part is find the velocity of P in terms of I and J. So that one is nice and simple for part one. All I'm doing there for the velocity of P is going to be, right, that's velocity of P. Because it is 20 kilometers and it's moving north, you're going to have just 20J. You can have plus 0Y if you want, it makes no difference at all. Part two of this then, the velocity of Q in terms of I and J, and we know it's going southwest, so we know that it's going to be the velocity of Q is going to equal 10 root 2, and we have cos 45. That's my I part. I have 10 root 2 sine 45. That is the J part. It's going south and west, so it's going to be a minus and minus. So I'm going to find that that is minus 10I and minus 10J. The third part then is finding the velocity of P relative to Q. So that's going to be P minus 10I minus 10J. So we're going to end up adding those, so it's going to be 10I plus 30J. If we were asked for magnitude and direction, we would now do that. But we are actually asked then for this part to do the shortest distance. So the shortest distance. So for the shortest distance, what I'm going to need to do is I'm going to need to draw it out. I know at a certain stage that there was a distance of 50 between them. So I'm going to just draw a line with 50 in between the P and Q, and it says that if this is 50, I'll do it on the bottom, that's 50 kilometers, and we know that P is positioned due west, so this is going to be P and this is going to be Q. So that's the first line. The next line then that we want to use is our VPQ line. So this is the velocity of P relative to Q. It's 10I and 30J, so we know it's going to be going in this direction some way because it's north and west. What I'm going to do is I'm going to use my magnitude and direction to find at what angles and to find at what speed. So when I use my magnitude and direction, I don't really need the magnitude, so I'll leave off that. I'll just do the direction. So the direction is going to be the tan of the angle that we're looking for is going to be opposite over adjacent. That's 30 over 10. So my angle is going to be the tan inverse of that, and that is 71, and I'm just going to round to 2 decimal places degrees. So when I draw in this second line, I have 71.57 degrees. I am looking for the shortest distance. So to find my shortest distance, what I really want is to finish off this triangle, but I want to end up at 90 degrees to this line here. So let's just say that that's 90 degrees and make it a little bit better. I'll make that Q line a little bit longer. So there's my 90 degrees. I want to find the length of this bit here. So I can see that my PQ, that is the hypotenuse because it's opposite to the 90 degrees. I know that then this is going to be the opposite here because it's opposite to the other angle given. So I can use sine in that case. So I'll have the sine of my 71.57 is equal to my opposite over my 50. So it's going to be 50 sine 71.57 is going to be my opposite. And that is giving me 47.44 kilometers. So that is my shortest distance.